Socratic Math Tutor here. So today I want to answer the question, how do you write down the factors of a number by hand? So a good method should have low probability of mistakes. It should work decently well for numbers up to about 1,000, and it should produce the factors in ascending order. So long story short, the idea is basically this. First, we're going to prime factorize. Then we're going to use a systematic method to list the factors. And obviously the idea is to use the prime factorization to make that work. And finally, we'll use the merge sort algorithm to get them in ascending order. So let's talk about each step one at a time. So step one is to prime factorize. For example, suppose we're interested in the factors of 180. Okay, let's build a prime factorization tree for this. So I know it can be broken down as 10 times 18. 10 can be broken down as 2 times 5. 18 can be broken down as 2 times 9. And all of these are prime except for 9, so we'll just break that down a little further, and there we have it. So because all of these bottommost nodes are prime numbers, that means we're done. So we can write 180 equals 2 times 2, so that's 2 squared, times 3 times 3, times 5. So for step 2, we're going to use this. We can get rid of everything else. And what we need to do is list the factors systematically. So to make our job a little bit easier, it's often good to rewrite the number that you're trying to find the factors of slightly differently to just ascending order. So what I want to do is put the number that's hardest to multiply out of these three on the left. So I'll put the 3 squared there. And then the other two numbers will go on the right. So the idea here is that because 2 and 5 are both factors of 10, and because we work in a base 10 number system, hence multiplying by these numbers tends to be quite easy. It's easy to double a number. It's easy to multiply by 5. On the other hand, multiplying by 3 is just a little bit more finicky, and so I've put that on the left because it's kind of the hardest of the three. So 180 equals this. And by the way, if you don't agree with me that multiplying by 3 is a bit harder than the other two, that's totally fine. You can put the numbers in whatever order makes sense to you. But I do recommend just putting the hardest number from your point of view first, then putting the next hardest after that, etc. Okay, so let's start off by writing down the factors of 3 squared. So we write 1, 3, and 9. Now we'll draw a line. Okay, so now I copy this number down. And because I have a 5 here, I multiply by 5. Put a line there. Copy this number down. Again, I'm going to multiply by 5. Copy this number down. And again, I'll multiply by 5. Finally, for the last line, which is going to be huge, by the way, because 180 has a lot of factors, we go through essentially the same process. So we copy the 1 down, and we're looking at this 2 squared, so we need to multiply by 2 and multiply by 2 again. So we get 1, 2, 4. We draw a line, copy the 5 down, double and double again. Line, copy the 3 down, double and double again. Line, copy the 15 down, copy the 9 down, and copy the 45 down. And there you have it. There's all the factors of 180. They're not written in ascending order, but they're all there and we've got no repetitions, so we're pretty close. So part 3 involves rewriting these in ascending order, and I'm going to recommend that we use the merge sort algorithm. Okay, a sorting algorithm is just an algorithm for writing things in ascending order. And merge sort seems to be one of the fastest. So to get started, what we should do is kind of collect things into ascending lists. So here's an ascending list of numbers. 1, 2, 4, 5, 10, 20. And here's another ascending list. 3, 6, 12, 15, 30, 60. And here's another ascending list. Now we need to merge these sorted lists in order to build a bigger sorted list. And the way we do that is by starting off a pointer at the first number in each of these lists. And then we just compare these numbers. So we compare 1, 3, and 9. Obviously, 1 is the smallest of these numbers. Now this moves over. We compare 2, 3, and 9. 2 is the smallest. Compare 4, 3, and 9. 3 is the smallest. So now we're comparing 4, 6, and 9. We put 4 down. This moves over. We put the 5 down. This moves over. Now 6 is the smallest, so we'll put that down. We'll bump that over. 9 is the next smallest, so we'll put that there. Put an arrow there. And you'll probably notice that now that I'm not reiterating what three numbers we're comparing, the process has actually gotten a little bit more confusing. So it's easier to make mistakes if you don't think to yourself, okay, what are the three numbers I need to compare? And so I actually did that on purpose just to help emphasize that it does get confusing when you leave that out of your mental verbalizations. And so to create a bit of contrast, I'll go back to the original approach in which we're mentioning all three numbers. Okay, so we're comparing 18, 12, and 10. So 10 goes down. Now we're comparing 20, 12, and 18. 12 goes down. 20, 15, 18. I put 15 down. 20, 30, and 18. Put 18 down. 20, 30, and 36. Put the 20 down. And obviously at this point, we can sort of forget about this list because we've included all its items down here already. So now we just need to look at these two. Okay, so let's compare 30 and 36. 30 goes down. We're comparing 60 and 36. 36 goes down. Comparing 60 and 45. 45 goes down. Comparing 60 and 90. Obviously 60 goes down. And now the remaining numbers from here are tacked on the end. So there's our answer. We've written down all the factors of 180, and we have them in sorted order. So next time you're faced with a problem like this, don't use an ad hoc method. Don't just kind of do your best and wing it. Definitely start by prime factorizing and then building a table like this. And then finally, at the end, once you've got your factors, sort them using merge sort, and with high probability, you'll get the correct answer.